Okay, Ji. So this is the situation. We have seen the two circuits. Now let's take a look again. If we change the direction of uh, the DC source, the V bias, what will happen? Let's see. ठीक है जी. अगर इस circuit में, in the same circuit, if we change the direction of the V bias, what will happen? Let's see. So we have resistor R1, we have the AC source, we have the diode, and then to a diode, what we do, we change the direction of V bias, and as usual, we have RL, and we are taking the output as RL. We are providing VIR, and this is our V bias. And again, we will considering point A or A. Now, what will happen? Again, when the positive half cycle comes, what will happen? And what is the point, right? So we say that we have the positive cycle or here. So when the positive half cycle comes, what will happen to the circuit? So or here, very interesting point, which is there. As you can see that the diode which is being connected to V bias in such a fashion that during the positive half cycle or at the start of the positive half cycle, V bias potential which is connected to the P side, it is V bias is connected with the positive side over here, right? And once it is being connected to the positive side, so this means at the start, the diode is being short circuited or the diode is forward biased. Or in the ideal case, we will say that the diode or the switch is closed at the start, right? When the switch is closed at the start, so what is the situation? This means that the output over here, because once the diode is short circuited, so this means the circuit will be looking like this. The switch is closed, or the or the what we can say that the diode is in the on state even before the application of the uh, input Vi, right? And the potential over here is A is as the input is rising, right? So the output which we are taking across RL, So the output is being held at the value which is equal to V bias, right? So this means at the very start, at the very start, the output is being held equal to V bias, right? Output is being held equal to V bias. Now, when the positive cycle comes, so what we will say that the input is rising over here, right? And this is the point which we say it is V bias. So once the input is less than V bias, the output is being held at V bias. When the input reaches the value equal to V bias, right? This means the Vi reaches the value equal to V bias. So at that very instant, what will happen that when the input reaches or the potential at point A reaches to a value equal to V bias, so this means that the diode will have a transition from the on state to the off state. And when it will have a transition from the on state to the off state, so this means the diode will act as a open switch from the closed switch, right? So we will have a transition from the on state to the off state of the diode. And once we have a transition from the on state to the off state, so this means at that very instant, when the input rises above, when the input rises above and goes towards its peak value, so the output will follow along the input, right? And when it is getting down, the input is getting down over here. So at that instant, when again the input is getting equal to V bias, so again the diode will become from the open switch, it will become a closed switch, or this means we have a transition from the off state to the on state of the diode. So this means the output will be something like this. Are you with me? बात समझ में आई है जी? Are you with me?
जी सर.
Right? So you can see the output will be something like this, which we have shown it over here. And again, when again the negative half cycle comes, the diode will remain as an closed switch. And when it will remain as a closed switch, so this means output will be held at a value equal to V bias. Are you with me? Question? कोई question है? You can ask me.
No sir.
Okay, जी. Now, again, what we will do, we change the direction. Okay, we change the direction of the diode as well as the biasing potential V bias, and we will see what will happen now. Now let's see, we have R1, we have the diode, and we have the V bias. With this, we are providing the input VI over here, and again we have the RL over here. We have V bias, and again you can see the V bias is again you can see V bias is connected in such a fashion that it is making the diode in such a way that the negative side of the diode is being held with a potential V bias, right? So, and this means that the diode is already being in a situation where it is short circuited or the switch is closed, right? And when the switch is closed, so what will happen? That as you can see, we have V bias. So due to that, what will happen? That the circuit will be looking like this. So the diode or the switch is already closed due to this V bias, right? And the output over here means because V bias is a potential, this is the negative side and this is the positive side of the V bias, VI, and we are taking the output across RL as usual, right? And we have R1. So this means V bias is making the output over here. So the output over here will be looking like V out, and this is minus V bias, right? So the output is already being held at minus V bias. So for the positive cycle, because this end point A will be positive, and once it is positive, it is keeping the diode short circuited, and this means for the whole positive cycle, the output will be like this. Okay, when the negative cycle comes, so for the whole positive cycle, the diode will be short circuited. So when the positive cycle comes, so this means for whole of the positive cycle, the output is being held at minus V bias. When the negative cycle comes, right, and we say this is minus V bias, we say this is minus V bias. When the negative cycle comes, so this means when the negative cycle comes, so now this side is negative, this side is positive. So this means the potential at point A will be now negative. When the potential at point A will be negative, so as long as this negative at point A is less than minus V bias, the diode will remain act as a short circuit switch. At the point where the potential at point A becomes equal to V bias, So at that very instant, we have a transition of the diode from the on state to the off state, right? So what we will say that all along or here till this point, so on this side of the line, the diode is in the on state, and once the input is getting beyond V bias over here, so this means the diode will go into the off state. And when the diode will go into the off state, so the output over here will have the negative peak like this, right? And again, when the input decreases its value in the negative direction, and once it becomes equal to minus V bias, so again we have the output which is being equal to minus V bias. Reason is that the diode will have a transition from the off state to the on state, right? Are you with me? Question? कोई क्वेश्चन है जी? Anyone having any question? Okay, so these are the outputs when we are considering the diode as an ideal diode. Now getting back to the circuit from the start, that what if the diode is not being considered as an ideal diode, but the diode is being considered as a practical diode, right? So if we consider the diode as a practical diode, in the first case, that was the positive limiter circuit. If we consider the diode as an practical diode, so in that specific case, the output which was being drawn over here, so for the positive half cycle, we said the diode was behaving as a short circuit switch, right? So now in that case, to overcome the barrier potential in case of silicon, the barrier potential is 0.7 volts. So this means the output over here for the positive half cycle, it will be 0.7 volts, right? Are you with me? ठीक है जी? Are you getting it? Previously, we considered the diode as an ideal diode. Now we consider the diode as a practical diode. When we are considering the diode as a practical diode, so to turn on the diode in the positive direction or in the forward bias direction, the potential across the diode will be 0.7 volt if it is made up of silicon, and it will be 0.3 volts if it is made up of germanium. But in most of the cases, we will be considering the diode is made up of silicon, right? So therefore, we say the potential in the positive direction will be equal to 0.7 volts, right? And same is the case when we consider the negative limiter circuit. In the negative limiter circuit, we considered previously the diode as an ideal diode, and in that case, we obtain the output like this. But now, if we consider the diode as a practical diode, so in the positive half cycle, we have the positive half cycle, but in the negative half cycle, we have a potential which is equal to 0.7 volts over here, right? This is 0.7 volts with 0.7 volts over here. And that is in the negative direction over here. So we will say minus 0.7 volts, right? So in the same way, are you with me? Question? Any question up till now? आवाज आ
No,
रही है?
sir. Thank you.
ठीक है जी. Okay, so again the when we consider the bias circuit, so bias limiter circuit, again we say we have seen that what happens when we consider the diode as an ideal diode, and we obtain the value in the output like this, right? But now in this specific case, we will be considering the diode as a practical diode, right? So the bias potential across this point A, right? So previously we said that once the value reaches to the value at point A equal to V bias. But now in this case, we will say that the value at point A should reach V bias plus zero point 0.7 volts, right? So once it becomes the value reaches to V bias plus zero point 0.7 volts, so then we will have a transition from the off state to the on state over here, right? So the potential over here needs to be V bias plus zero point 0.7 volts. And at this specific value, we have the output that will be for the positive half cycle, right? And for the negative half cycle, the situation is the same. And the same is the case with the rest of the circuits which we have discussed. That what happens when we have the output. So again, it will be V by in this specific case, it will be minus V bias and minus zero point 0.7 volts. So you can adjust it accordingly. Okay, ji? So this is how the circuits will be behaving when we have the biasing potential and diode, because in total they can have 4 combinations, right? And these 4 combinations, the outputs are actually totally different from one another. So you should be very careful when you are dealing with this, right? Any question? Now, as you can see, that in these circuits, the diode was in the parallel branch. But what if the diode is in the series branch, right? And if the diode is in the series branch, so what will happen? Let's see. Now we have the circuit diode, and we have the resistance. We have the resistance, and we are applying the input, or we are taking the output across RL or here V naught and VI, right? So this is basically the simple circuit which we have seen in case of the half wave rectifier circuit, right? So the output in that specific case, if we consider the diode as an ideal diode, so for the positive half cycle, we have the output like this, and for the negative half cycle, the output is a flat out if we are considering the diode as an ideal diode, right? Okay, now what if we add we add what if we add a V bias in series to this diode, and we say V bias over, right? So again, we have the input VI over here. Okay, ji? Now what will happen to the output? Again, we consider the diode as an ideal diode. J, what will happen to the output? जी आउटपुट क्या आएगी? Anyone? If V bias is less than the maximum value of Vi, and we say the maximum value of Vi is Vm, right? What we say V bias is less than Vm, right? What will happen? जी क्या होगा? What will be the output? Anyone? So again, what we can see that the for the positive half cycle, as long as the input is less than V bias, right? So the diode will remain as an open switch, right? Why? Because the negative side of V bias is being held to the P side of the diode, right? So as long as the input is less than V bias, the diode will remain as an open switch, right? Now, once the value of input Vi reaches to the value of V bias, Vi reaches to the value V bias, at that very instant, we have a transition of the diode from the off state to the on state, right? And once we have the transition from the on state to the off state, so this means we will have now the current that will be flowing in the circuit. And once the current that will be flowing in the circuit, so this means we will have some output for the positive half cycle, right? And the value of that will be, because if you see what we can say, that if this is the value of V bias and this is Vi getting to its maximum value Vm, right? So till the point Vi is less than V bias, so the diode is in the, what we say, the diode is in the off state. And once Vi getting crossing the V bias, so over here the diode is in the on state, right? So if we just take this and we say, if we take the projection of this on the output side and we say this is V naught, so this means that only during this peak, which is Vm minus V bias, we will have the output like this, right? So during this time, we will have the output like this. Okay, ji? And the rest of the time, it will be in the off state. And for the negative half cycle, again, the diode remains in the off situation, and when it remain in the off situation, so the output will be a flat one during this time and during this time, right? Question? Anyone having any question? The question है जी? Are you with me?
Yes,
Anyone?
sir.
जी क्वेश्चन है?
No, sir.
Okay जी. So again, we can have different directions of the diode and different directions of the biasing potential, right? So what we can have, let's suppose we change the direction, or what if, okay, so let me just draw it. So what we have, let's suppose we say we have this V bias, and then we have the diode, we have the input, and we have the output RL, and we have V naught, and we have VI, and okay. So now in this circuit, what will happen? Okay, what will happen? That again we consider the diode as an ideal diode, and we are providing the input over here as VI, and the maximum value is VM over here. As you can see, the V bias is actually attached with the positive side of the P. So this means the diode is already okay. Ji. So what will happen? That we have V bias, which is directly connected with the diode, and the positive side of the V bias is being holding the diode in the short circuit position, right? So due to that, what will happen, that the diode is already in the on state, right? So as long as the positive side and the V bias, they are being held together, so this means the output will be starting from, or here we say that is V bias, right? And then when the input rises for the positive cycle, so the output will be rises to the value over here, which is Vm plus V bias, right? So it goes over here. Then as long as it is positive, so the input is positive, output will be there. And as long as the V bias, this means it is crossing V bias, input is getting to the negative side. Again, as long as the potential at the diode, taking the diode to the value that it remains in the on state, we have the output, right? But once the value of the input over here is equal to minus V bias, so that at this point the output will be equal to 0. And when the output will be equal to 0, so then we will have this output, which is a flat output. So this means as long as we are in the on state, and over here we have the off state of the diode. And this means there we can have a transition from the on state and off state when the value of input is getting beyond a value of minus V bias, right? So in this way, we can have different outputs. So, okay, with this, what I will say that you draw the circuits which I have shown you that for the practical diodes, right? So this the condition which I have shown you over here. It is for the ideal diode. So draw these two circuits, this one as well as this one, for the practical diode, as well as changing the direction of the biasing potential and the diode. And in the end, we can have four circuits like this, that V bias diode and RL, right? So changing the direction of V bias and changing the direction of the diode, we can have the four circuits that can be there. And you can actually draw the output accordingly. Okay, Ji. With this, there are a few examples which are given in the book. So the example is example 2.10, 2. Okay, sorry, 2.18, 2.20, and 2.21, right? So these are the assignments. Okay, Ji. So example 2.18, 2.19, 2.20, and 2.21 are basically the assignment. Okay, Ji. So any question? Anyone having any question? कोई question है जी?
No, sir.
Okay, Ji. That's it from my side today. Okay, Ji. Okay, thank you.
Thank you, sir.
Thank you.